Welcome everyone to where we are putting together solutions for those maths and science topics we are getting problems with. Today we will be looking at algebra and specifically expanding brackets. This is the first video in this mini-series. So feel free to comment or ask questions in the description down below or post which topic that you may need help in so we can make a video for you. A little revision here that we must make sure that we're very good at multiplying or dividing two terms. If the terms have the same signs, then we will have an addition. If the terms have different signs, like a positive and a negative, then the answer will be negative. If we have more than two terms, we work with two terms alone, find the solution, and then continue with the third term. Hopefully, we will recognize that this topic is very familiar to us. As we look at this question, how many plums do I need in all so that the three kids each receives 21 plums? Now, you've been doing this sort of question many years, right? And if we want to find out how many in all, it would pretty much be a short multiplication question. So we say 21 times 3, and then we put our equal signs here, as you know. We see 3 ones are 3 and 3 twos are 6. So we're going to get 63. Right? Simple enough. However, we can write the same question a little differently. So it can look like it like 3 times 20 plus 3 times 1. Just recall that it is not 3 times 2. Those 2 are 2 tens, which is 20. So that will give us 60 plus 3 ones are 3. Right? And we can solve it there. 60 plus 3, 63. Now, hopefully we can see that what is on the left side is the same as what is on the right hand side. Right? But what we can do on the right hand side now is actually put some brackets. We can easily see where the multiplication is taking place. Right? And from the topic before that we've been doing, which is factorizing, we can see that there's a 3 in both of these brackets, which is what we were calling the HCF, or the highest common factor. So we can actually rewrite this as 3 20 plus 1. Right? So what we did is we really looked at 63 and we moved upwards, right? Which means that we are adding brackets, right? And the word for that is factorize. And this is what we've been doing for the last few classes. If we're coming downwards, we start in with brackets. So what we want to do is remove the brackets. When we remove the brackets, it's called expanding brackets, which is the purpose of our video today. Let us consider the same exact question with the plums and the 3 children. Remember, the question was 21 plums at 3 children, and that will give us, using short multiplication, 63. Now we can do the same question using a rectangle, where we take the length of the rectangle to be 3 and its width to be 20. Similarly, we'll take another rectangle with the same length of 3 and its width of 1. So if we can convert this to look like the same question from before. 3 times 20 plus 1, or 3 times 21. So when we find the area of the rectangle on the left hand side, that is 3 times 20, that will give us 60. And the area of the rectangle on the right hand side will be 3 times 1, which is 3. And that gives us our solution of 63. We now look at the same example we did in the first part 1 video of factorization. Right? And the question, which was factorize the following, really means adding brackets. So the question was, what factorize 15 squares plus 10 circles? And pretty much what was shown in that video was we needed to now go and find the HCF, the highest common factor, which worked out to be 5. Right? So now we rewrite this, and this will be equal to 5 times 3 squares and 5 times 2 circles. And we can now extract the 5 since it's the same in both of them. And what we are left with would be inside the brackets 3 squares plus 2 circles. Now, if the question was given expand the brackets now, what that would mean is that we have to remove brackets. So if you remove in brackets, the first line will have brackets in it. So here it is, 5 brackets 3 squares plus 2 circles, which is exactly the last line in the one on the left. So how do we do that? We draw a little arrow on top here, which indicates that we have to multiply 5 times 3 squares. And we draw a second arrow because there's a second term in the bracket, right? So it's 5 times 2 circles. And if there was a third term, then we would draw a third arrow. So that will now give us 5 times 3 squares and 5 times 2 circles. And we can solve it now. 5 times 3 is equal to 15 squares and 5 times 2 is equal to 10 circles. So pretty much what you recognize here, that if you look on the left hand side to the right hand side, they're exactly the same except written in the opposite order. The one on the left, the factorizing, it had no brackets and they asked us to factorize it, right, to add brackets and end up with a product at the bottom. On the right hand side, there's a product given 5 times the brackets and we need to expand it, which means to remove the brackets, and we ended up at the base there without any brackets. Thus, expanding brackets is exactly opposite to factorizing. So let's look at the same example from before, solving it now using the area method. The question was 5 times 3 squares plus 2 circles. And if you remember what we did, we multiplied the 5 times the 3 theta and then we multiplied the 5 times the 2 circles. So if we consider this to be like the rectangles using the area method, then the width and the length of the first rectangle will be 5 and 3 squares. And the 2 circles will be for the second rectangle. So we can actually put in the brackets here so it looks exactly like the question there. Now finding the area of the first rectangle, 5 times 3 squares will give us 15 squares. And 5 times 2 circles will give us 10 circles. So our answer will be 15 squares plus 10 circles. Thus, the area method can be used to expand brackets as seen here. So we're going to continue expanding the brackets with some more examples. So just remember that expanding the brackets means to multiply and thus remove the brackets. So in our first example, we have 6 hearts multiplied by the brackets, 3 hearts minus 2 pi. So in order to do this, we multiply the 6 hearts by the first term and then by the second term. So this will give us 6 hearts times 3 hearts and 6 hearts times 2 pi. If you look at the signs, you will see that it is plus 6 times plus 3. So since the signs are the same, then that will give us a positive. And in the second multiplication, it's plus 6 times minus 2. So there's a plus and a minus. Those are different signs, therefore that will give us a negative. And this now will give us 6 times 3 is equal to 18. Heart times heart is heart squared, minus 6 2s are 12, heart pi. And we have removed the brackets. The question has been completed. Let's look at another example. And here we will see that we're using 3 terms. Minus 8m times minus 6m squared plus 7n minus mn. So we multiply the minus 8m times the first term, and then we do it by the second term, and then the third term. So this will give us, remember that if we look at the minus from the 8 times the minus from the 6, since the two signs are the same, that's going to give us a positive, and 8m times 6m squared. And we look at the second multiplication, a minus by the 8 and a plus by the 7, two different signs, so that's going to give a negative, so that will give us 8m times 7n. And in the third multiplication, we have minus 8 and minus mn. So we have two same negative signs. So that will give us a positive. So that will be 8m times mn. This now works out to be 8 times 6 is equal to 48 m times m times m cubed. 8 times 7 is equal to 56 mn, and the negative sign holds, and 8 times m is m squared n. And we've completed the question. The area method for the same two examples that we just did. So in example 2a, remember we're expanding the brackets, which means we're multiplying. So we're using it just like length times breadth to give us area. So let's use the length as 6 halves, and we're going to multiply it by 3 halves. And then do the same thing with the second term, the 2 pi. So that means 6 halves is the length, and 3 halves will be the breadth for the first rectangle, minus 2 pi for the second rectangle. So 6 halves times 3 halves will give us 18 halves squared. And if we multiply the second one, 6 2s are 12 half pi. So the question is complete. So we get 18 half squared minus 12 half pi. And when we look at the second example there, 2b, we'll see that when we expand the brackets here, there are 3 terms. So that means that we're going to be multiplying minus 8m by the first term, by the second term, and by the third term. So we make the length minus 8m, and for the first rectangle, we make the breadth minus 6m squared, and the second one plus 7n, and for the last one minus mn. So that now, when we do the multiplication, will give us 8 6 are 48, m times m times m is equal to m cubed. And we have two negatives, two same signs, so that will give us a positive. And when we multiply 8 by 7 for the second rectangle, that will give us 56 mn. And we have a positive and a negative, so that means this is minus 8m squared. And for the third term now, we have to multiply the minus 8m by mn, and that will give us 8m squared n. And we have two negatives, so that will give us a positive. And we've completed the question. 48m cubed minus 56mn plus 8m squared n. We have posted an exercise here for us to practice the skills that we have learned in this video of expanding the brackets. We can pause the video here and work it out. And when we restart the video, on the next slide, you will see the solutions. For those of us that are getting problems, I have posted a link in the description below, and that will carry us to the actual complete solutions of every question. These are the solutions for the exercises that were given before. Thank you for joining us with our video, and feel free to hit the link and go on to part 2, where we will be expanding and simplifying two linear expressions. Don't forget to add in your comments if you need any help in any particular topic, so we can make a video for you. And don't forget to subscribe. Bye.